welcome everyone to tonight's session of Reaching Out While Locked In. Tonight we have Dr. Steve Higgins, and Steve, you're one of the few people that I've worked with that I think has been here longer than I have. So I think you were here when I got started, and so have had to see your face for a long, many years, and few changes, and you've seen a few changes in mine.
Yes.
But appreciate you coming on tonight. I think most of the audience is probably familiar with Steve. He's very active across the state, works in a lot of different areas, most of it having something to do with environmental stewardship. And that's really no different tonight, but a heck of a lot of practicality, Steve, in what you're going to talk about tonight with simplifying the winter feeding. So we do appreciate you being with us tonight. Now I'm going to turn it over to you. If anybody has any questions, type them into the chat, please. And we will get to those as we go. If it seems like something I need to butt in, Steve, I'll let you know, but otherwise we'll wait and answer all those questions at the end.
Yes, sir.
Thanks for joining us, and Steve, it's all yours.
Okay, thank you very much. Okay, so tonight's topic is going to be a little different than what you're normally used to. Basically, we're going to talk about simplifying winter feeding. It's basically saving time and money through simplicity and elimination. Before we get into that, basically what this is basically, this is about perspective. So I want you to look at this picture right here, okay? It's a couple bats hanging upside down, okay? But then I can take that same picture and I can flip it upside down. And to me, it's completely different. Looks like they're, I don't know, doing a jig or something like that. Okay. So it's all about changing perspective. All right. Also, I want you to read this sentence right here. All right. Okay. Now count the F's. Count how many letter F's are in this sentence. I'm betting that most people came up with about 3, okay? But there's actually 6, okay? So that's what this is just kind of get you to think about perspective, because in my opinion, I subscribe to this philosophy that 95% of what we see every day is invisible to us. So the point of this presentation is hopefully to get you to see your farm with a different set of eyes so that you might notice some things, okay? So with that said, we're going to talk about winter feeding. And so this is just a typical picture of some cows basically having full access to some round bales where they're eating some of it, they're laying down on some of it, knee deep, hop deep. There's one over here, a little calf over here to the right, perfect place for it to get stomped by someone other than its mother, okay? And then what they're doing is they're urinating on this, they're defecating on it, they're laying on it, and they're basically commingling this hay in with this mud. And once they do that, they're never going to look at it again. All right. And so this photograph right here is the same image. Okay. This is what it looks like in the spring. Now there's some calves in here standing in a puddle. This is looking the other way. That is a significant amount of hay waste. Okay. In this particular situation, a little over 100 bales were fed, but the cattle only required about 50. So basically they fed twice as much as they needed to, and they waste half of it. Okay. This is a graph basically showing 0% waste going up to 100. This is for no feeder. You're looking at starting off around 36% up to about 97% waste with about an average of 58. But if you provide some sort of containment like a ring feeder, now we got a nice cluster of data at about 10%. The point is providing containment on this hay bale reduces the amount of waste and loss, okay? This is Eden Shell Farm, where I've been working for about 7 years. Basically, this is a standard feeding area that the University of Kentucky used back when we controlled the farm. So, and this is copyrighted by Lem Cooler. And this is on the other side of the fence, basically the same field. So we've rutted it up with tire traffic and vehicle traffic, basically feeding concentrated diets. But then on the animal side, there's over a foot of soil missing, and it's just eroded. It's down at the bottom. It's not at the bottom of the hill. It's basically in the Gulf of Mexico. So there's a lot of significant soil loss here, a lot of drudgery, and your output is grass. And the only thing we're going to be able to grow here is cockivores, okay? So basically, it came up with the idea of doing the fence line feeders, where basically we don't have to go into the field. You can just basically come in the fence line off the road and establish these cubbies or fence line feeders, which allows you to feed without entering the gate, without getting off the tractor or anything like that, or figuring out where to put the roll bale. And so we did several different models of these fence line feeders at the Eden Shale Farm just to demonstrate different economies of scale, but all of it is on heavy traffic pads and all of them are available from the road, okay? And this is just a view looking from the other side. And we got concentrated bunkers in between the hay feeders, which allows you to use the same area, hardened area, for feeding two different diets, roll bales versus concentrated diets. It also allows you to count the cattle and check on them because this is where they want to hang out. There's a windbreak that shelters these animals. This is the amount of hay loss right here. This is 12 inches right here. This was taken in the spring, so it's already germinating, but they took this down to the concrete. So there's very little waste. And this is in the spring also, and you can see around this feeder. So there's that. And so here was some data that someone did, and it was on a hardened surface, and they evaluated a cone, a ring, a trailer, and a cradle feeder. And then what you want to know is all the body conditioning scores are the same, all the weights are the same. What you want to look at is percentage of hay waste. So the cone wasted 3.5, the ring wasted 6.1, 11.4 for the trailer, 14.6 for the cradle. And then you also want to look at the body weight as a percentage, or their intake as a percentage of the body weight. So 1.8%, 1.8%, 2%, 1.8%. So what this is telling me is what we already know is the cows are basically going to eat 2% of their diet, or 2% of their weight in a diet, provided it's got the correct nitrogen and total digestible nutrients and all that kind of stuff. But what you also notice is the percentage of the hay waste is dictated by the feeder. So the cattle aren't wasting the feed, it's the design of the feeder that creates that waste. Now let's say, I like to look at logistics. So let's say a normal cow in a winter feeding season needs 3 roll bales of hay. Well, considering or accounting in the waste, instead of feeding 3 roll bales, you're going to feed 3.11 with a cone, 3.2 with a ring, 3.4 with a trailer, and 3.5 with a cradle. But if you do not have a feeder, you're looking at feeding 7.14 bales. That means you're feeding over twice as many bales as any of these other systems because you do not have the containment, all right? Now let's say that those roll bales cost 25 bucks a piece, which is a real minimum, okay? You're looking at $77 versus $178. So there's a $100 difference in this data by just providing some sort of containment, all right? So then you go to this. Buddy of mine took this picture and sent it to me to demonstrate an issue, and now I'm showing it to you. And I don't like to pick on producers, but is this a historic feeding area? Well, yes, it is. Is it wintertime? No, it is not. And let's just assume that there's 12 animals right there. Well, I can get 12 cows or 12 beef critters around a ring feeder. So with containment, I can save $100 per animal. So I can save $1,200 in the first year by providing some sort of containment. But I have to buy the ring, okay? So I can spend $200 and get a really good ring. So I'm going to make or save $1,000 the first year and $1,200 every year after that, as long as the integrity of that ring lasts, okay? So that's a significant savings, in my opinion, $100 per animal, which could pay for one of these fence line feeders fairly simple. But here's my point. Fence line feeders are not going to solve all your problems. They're not going to solve and eliminate mud on your property. It's a good start, but there's more to it than that. You have to look kind of big picture. Big picture for me is thinking about efficient feeding concepts, where basically feed should be moved as little as possible from the point of production, the hay field, to the cow's mouth, wherever you're feeding. Feed should be moved in bulk. Feed should be self-fed. Feed should be consumed with as little waste as possible, okay? So here's an aerial photograph, basically, of the fence line feeders along this farm road, and here they are, staged, all the different varieties. You can see the brown, which is basically in the newer deposits, but basically I got a green tint of grass in this field because they're not tearing it all up. But the point is these hoop barns is where the hay is stored. So how far do I have to drive to basically load up these structures from these hoop barns? Basically, you need to say not very far. But the farther this distance becomes, the more dysfunctional this design is, okay? And so what is also going on here is in this design, okay, right here next to this gate, there's a little dot right there. That's a 2-hole water, okay? If you have water and food in the same location, there's no reason for those cattle to leave. What you want to do as a producer is motivate the cows to practice their own motivations. So they need to eat and then they need to get a drink. So you motivate them to move and go do what they want to do, okay? So after they eat, they're making a path and they're heading over, because what I'm doing is I'm shutting this water down in the wintertime, and we developed a spring right here that feeds a tire water that's right here in between these two fence lines. So one water serving two pastures. So after they leave, they walk over here, they get to eat, and then they go down to the bottom to get out of the weather, okay? But this is a summit position, okay? Because I want that water to drain from this place. I want it to drain away from the cattle. I don't want drainage going into that feeding situation. So what this is basically, you know, with this hoop barns and these feeders located right here, is basically a feeding layout, okay? And it's also, so farm layouts in general, the whole farm, is basically the relation of the fields, the gates, the lanes, the waters, the roads, etc., into the buildings to each other, and also the inside of the buildings as far as the circulation of how things move in the building. That's all important as far as a layout. And a desirable layout is necessary in order to economize labor and enhance the value of the property. The problem is that farm layouts and infrastructure are usually given little to no consideration, which usually results in an arrangement that is neither simplistic or systematic for labor efficiency or livestock production, okay? So here's an example of a layout on a farm. This is a real farm, this is a real layout, and this red path right here is the path that this producer takes to basically feed his livestock, okay? And as crazy as this red squiggly line looks, that's not the crazy part about this. The crazy part about this is right here, it says repeat 8 times, okay? So this farm layout is basically diagrammed, all right? And then someone basically comes up and does this, and then they basically say, hey, let's change this around. Let's take the same farm property and change the layout. So this is the change. And so instead of doing what he was doing, which is going inside the paddock, now he is actually doing fence line feeding. And this term hardcore is basically a heavy traffic pad. Geotextile fabric and rock, concrete, whatever you want to make it, okay? But now he is fence line feeding, okay? And same layout, but he has reduced his efforts significantly, all right? This is the bull barn, which is at the Eden Shell farm. And one of the things that I wanted to look at was basically how people feed and just kind of do what I call a time motion study, okay? So if I can get this, all right, hang on, I got to get the laser pointer off. Turn this off. Come on, come on, come on. Okay, so, all right, so here's the bull barn, and this is a drone video. And so what I'm doing is I got a stopwatch, okay, and I got this video. So right when he passes this post, right now, I start a stopwatch, okay? And he's taking this roll bale around, and the deal is I'm like, okay, don't do anything different. I'm just gonna feed, so watch you feed, and I'm gonna time it. And this is not counting the distance that he took to get to the barn. This is just starting at that post. And there's a little bit of a clip out here, which I shouldn't have, but basically now he's got to unlock this gate right here, and he's got to back up this 85 horsepower tractor down this lane because of how the gates swing, okay? And then what this requires is you got a tractor and an operator, but you also need this person right here to basically open these gates, and also to watch out for escapes, which is this animal right here is getting ready to make a break for it, okay? And I adjusted the time for basically for this gate issue right there. Okay, so now, all right, here comes your escape, and he tries it, all right? So now he's gonna take this roll bale and he's gonna pop it into this ring, okay? And then basically he would go back to where he started, and then I stopped the stopwatch. So this took 2 people, an operator and this other person, took them 4.5 minutes. Now I'm saying, okay, let's do it my way, all right? And so he's going around, it's basically the same path, all right? He's coming around here. There won't be a skip probably for the backing up. Oh, there was a little one. All right. And so now at this point, he's getting on this artifact of a road because this road hasn't been used in forever. And then I went up to the siding of this perfectly good barn, and I cut holes in the siding so that basically what he could do is he could drive up and basically put this roll bale into essentially a cubby or a 2 roll bale feeder that's in this barn. Okay. So the difference here is okay, now he's done. And so this took 2.5 minutes, okay? And it only took 1 person and the tractor, all right? So the thing is when I do the math on this, okay, so my method at 1 worker at 2.5 minutes versus 2 workers at 4.5 minutes, okay, do a little bit of a cost benefit analysis. There was 72 bales that were fed at this barn, okay? Well, that is the difference of 1.5 hours using my method uses 5.5 hours, which is their method, okay? When you put a dollar value to this at a tractor and an operator at $30 an hour, that comes out to $45 to basically feed 72 roll bales. Conversely, the way they were doing it before required 2 operators, okay, a tractor operator and a helper at $40 an hour, that's $220, which is a 5-fold difference or a 500% difference, okay? You also have to look that the hay is inside and under roof, under the cubbies, versus the other roll bale is sitting outside in 6 inches of quagmire and it's actually getting rained on. And then, so we're assuming that the waste would be the same, but it's not. But I want you to remember this 500% or this 5-fold difference, okay? The other thing is gates, opening gates on a farm can either be effective or it can be a nuisance, okay? I have only been on one farm where the gates on the farm actually swung freely. Most of the time we're dragging a gate open and we're dragging it closed, okay? Because it's just not hung properly. And so there seems like an endless amount of time stopping the tractor just to open and close gates, okay? And so there was only one gate that, or actually 2 gates that need to be opened on their method, okay, versus 1 on mine, okay? And on some farms, I've heard basically producers say that they might have to open anywhere between 4 to 20 gates just to feed 4 or 5 roll bales, okay? That's where the nuisance part comes in, okay? And so here's the cubby, all right, that's actually in the barn. And then this is a 2 roll bale cubby. And it's kind of interesting to put this in because I'm using the existing post of the barn. All I had to do is add this one post, about 2.5 yards of concrete and 3 feed panels. And that's essentially, it's done, okay? But the thing this is nothing that's done in isolation. So here's the cubby. So we actually redid the floor as well, okay? Because this was a dirt floor. So we actually came in and we put in this grid, this plastic grid that you actually fill in with rock. And so when you come in and scrape the manure off this with a bucket, then basically, or blade, you're not going to go past this plastic. So you're not going to be hauling rock out of your barn. You're not going to be digging into the gravel and hauling that out as well. Something else to show you on this is by putting this hole in here to basically install this cubby, now we have actually increased the ventilation and the light that's coming into this barn. Sunlight is like the cheapest thing ever, but it's essentially absent on a lot of farms. And it's one basically ventilation and light basically go hand in hand. If one of them is missing, then basically you're going to have some sort of a deficit or a problem. This is another flooring system that we put in where basically we're using tire cylinders or tire treads or tread cylinders, where you basically cut out the sidewall of the tire, you lay that down and you backfill this up with rock. Same situation is happening when the bucket or that blade of this Bobcat comes through here. It cannot go past that 1.5 inch thick rubber, okay? The other thing too is the sidewall of this tire is actually holding that rock in place. And because of the containment of that tire, you don't get the deformation from lateral loads, which wants to push that rock out to the sides, okay? So I think for $1 a piece to put these tires in, I probably extended the life of this heavy traffic pad by 4 or 5-fold. I don't know, we'll have to see. So nothing's done in isolation. I put the feeder in, okay, but we also modified the flooring, we improved the ventilation, we improved the light, we added a manure storage structure, we also added shade structures in the lot that's adjacent, and a handling facility was already present, okay? So what we're doing is we're combining multiple activities at the same location, okay? We're gonna shift gears again, okay? Here we go. All right, so this is your typical tobacco barn that is no longer being used as tobacco. It's on a beef cattle farm. What do you do with it? Well, it basically becomes junk storage, okay? And when you store things basically 2-dimensionally on the floor like this, it's a significant waste of space because you lose all that cubic area up above it, okay? Now, this is a barn, a livestock barn, combination tobacco livestock barn that's on the Eden Shale farm, okay? The inside of it is no different than any other tobacco barn that I would see on any other farm. It is basically, it's junk storage, but there's a concrete floor in here, all right? And you're able to drive this tractor down the center alley. You should be able to drive this tractor through any one of these openings, but you can't. And that's one of those things of we have tractors now that do not fit in these barns, which is not a good marriage, okay? So anyway, I take this design or this idea of this barn, which was intentionally or designed for tobacco and livestock. And so we're not using it for tobacco anymore. So what I'm doing is I'm reprogramming that structure, all right? I'm gonna redesign it for something else. And the design that I went for is basically taking that center alley and making it into a self-feeder. So the length of this particular barn, we are able to stack 30 row bales of hay in this barn. And on this side, basically, I have a feed barrier that's on rails. So the cattle can come up on this approach. They stick their heads through, they start eating, and they have access to the entire section of row bales, 30 some odd bales. All right, so there's the bales that are in the barn. We actually stuck them too high. This was in June. Okay, so we harvested the hay and we moved it one time and we put it in this barn. We peeled off the strings and there it sits. Okay, and that's when we put it in June. All right. And then, so the other thing about it is if you take a recent picture of it now, this row bale here by gravity is now falling into this opening. So it's ready to eat. And so we don't have to do another thing other than basically let these cows have this around in January, and they're going to just go to town on it. Okay, so the hay is inside on this barn, so you're going to reduce your spoilage. All right. How many cattle does it feed? Well, it's only about 13 feet across right here. Your normal allocation is 2 linear feet per head, but this is free choice feed. It is there 24/7. So I can take basically this design of, say, 7 animals that can actually access at one time, and I can multiply that times 3, in which each animal now has about 8 inches to actually feed, which is not bad. Some people can, like to push it more than that, but 8 inches is a good amount. So I can now use this to basically feed 24 animals. So you figure the normal herd size in Kentucky is 27 cows. Basically, I've almost got enough hay in here, or I do have enough hay in here to feed for a month without firing up a tractor, okay? All right, so how much does this cost? All right, so for the rack itself and the track and everything, I spent about $3,500 on those materials. And then I also bought, I put in some heavy traffic pad, and I put in about 300 feet of fence and about a couple of gates. And yeah, and that's about it. So I do have some money in it. And so some people will look at that and go, well, that's a lot of money for 27 cows. But you have to look at it, again, from a bigger picture, right? Because nothing is done in isolation. So here is an aerial photograph of this particular operation. And so let me get this mouse or this pointer on. Okay. So this barn is right here. Okay. And it is in a field, a hay field, field 66, which is an end-of-fight free hay field. And so you wouldn't want cattle, winter feeding on this because you're going to tear it all to pieces. But what we did was we put this in the barn and put in these little yellow bars right here, which is additional fencing, which is 300 feet of fencing. Now we have cleaved off this little area, which is now a hub. And this hub has access to these woods and this other winter feeding area in 65, but that hub also has access to 44. So you can got this fluid movement of these cattle with rotational grazing. It also allows you to split the herd, so you can have a partial herd in 65, you can have a partial herd in 66 in this hub area that has access to 44. But the point is 66 is a hay field, and we're moving the hay from 66 into this barn. We're moving it once, okay? And now it's ready to go, okay? And this is just kind of zooming in on it. We put in a heavy traffic pad on the southern side, which is where all the sun's going to be. So that sun's going to keep this area clean in the wintertime if we were to get some kind of inclement weather of snow or freezing rain. This is the fences I put in, and also installed a gate. Well, there's actually existing gates were right here, and I added a gate that was over here. All right. So, and then this is a kind of rhetorical question, but I want you to think, what is the purpose of a barn? Okay. And most people are going to answer shelter, after they think about it a little bit. And shelter is a correct answer. Okay. But there are probably 8 purposes of a building, in my opinion. And if you number them in order, shelter would be my number 8. So there's 7 more that have a higher priority than that. Okay. So a building, when considered as a static structure, okay, is basically useless. It can only serve as a shelter or as storage space, whereas its real value is measured in terms of what it can contribute to the productive capacity through planned arrangement. And planned arrangement is the layout, okay? Control of the environment, which is basically, again, ventilation, adding sunlight, and facilities for storage and conditioning and management, sanitation, which is, again, manure cleanup and all that kind of stuff. And also the savings of labor, okay? So now we're going to shift again. All right. We're going to talk about the science of where. Okay. So this is the Eden Shell Farm. The border of the property is outlined in red. And so I've got it color coded. You can see some satellite images, which is basically showing you woods, which the cattle do not have access to. This dark green area is a set of woods that they do have access to, okay? The pastures are the light green and the hay fields are basically the tan, okay? The black is basically the roads that are going through the farm. And then right here, this little yellow dot is a centralized storage structure for the hay, okay? So, and I love maps. Maps is this way of providing you with a different perspective and a different way of seeing your operation, okay? They show you connections and patterns and relationships and problems as well as solutions, okay? So in this particular situation, what I've got is I've got the hay fields identified here as the tan. And these circles, these yellow circles are basically graduated, you know, and scaled for size. What those circles indicate is the number of bales that were harvested from those hay fields, okay? So all this hay is being harvested, it's moved down these roads, and it's taken to this centralized storage structure, okay? This image right here is also, it's got graduated symbols, okay? These are the places where they feed that hay come, you know, in the wintertime, all right? So you harvest it in summer and you feed it in the wintertime. So that's where these circles are. And again, there's your hay storage. Now, if you put both data points on there, this is what you'll see. All right, so the green is where you start, which is your hay field. You're going to move everything to the hay storage structure, and then you're going to move it from there in the wintertime, and you're going to take it to these red feeding sites, which is where you stop, okay? So if you look at this pattern, what we've got here is you're harvesting a significant amount of hay and moving it down these farm roads, and as you're moving it to this storage structure, you're passing up your feeding sites, okay? You're at this hay field, and you're passing up feeding sites to get to this storage structure, okay? So what you're doing is you're backtracking, all right? And so when I started noticing this, I started bringing it up to some producers, and I made the comment that you're driving your tractor too much, okay? And this one producer actually jumped on me. He jumped on me really good, and he scolded me, and he said, "I like driving my tractor," okay? And some people actually use this as therapy, okay, which is great. But if it's therapy, it's going to cost you more than $30 a hit to operate it. I'm going to charge you $300 because that's what therapists cost. But my point is what we're doing is we're compensating for a bad layout, a bad design by driving a tractor to bridge the distance that we have created, okay? So for instance, I got this area that's circled, this white circle that's around this, you know, heavily fed area that's right here. Well, what that is basically this large self-feeder, which has 32 roll bales in it, which can self-feed 32 roll bales. And what we did was we put this hoop barn over it this summer, okay? So now this is a storage structure for storing my hay, but that storage structure is also, again, a self-feeder. So you put the roll bales in there, we got them standing up, we peel off the strings, and again, we're done until it's time to winter feed. The animals come up on the heavy traffic pad, they come up on the concrete, they eat this, and it rolls back, okay? And then you can reload this thing if you need to from this area, and there's no gates to open, and there's no reason to get in with the cattle because you can load it without getting in with the cattle, and you can feed them without getting in with the cattle. So this area right here, this is a significant hay field right here by the size of that green dot, and I've got it circled, and basically this is where that Bar Optima hay field is, okay? So again, this is where the hay is produced, but now we've made a self-feeder right here and a storage structure. So again, we've just reduced the travel distance we have to do significantly, okay? And so then I started looking at all the other feeding sites, okay? There are 13 different feeding sites on this farm. And what you're looking at here is the time to feed round trip to go from this storage structure to that feeding site and back, okay? And I'm just going to tell you now before I forget, there was 300 roll bales that were fed on this farm last year, and they were all basically fed 2 at a time. Conversely, some of the structures I've just shown you will feed at least 30 or more, okay? So anyway, I got these times on here, and then you get out to these far ones. This is 30 minutes here and about 35 minutes here. But I just wanted to use a calculation of basically 20 minutes, okay? Just a 20-minute round trip just to show you how this looks like, all right? So depending on which hay field you come from and the 20-minute drive to feed after you've got it stored, you're looking at a cost of $21.60 per bale from one hay feeding field or one pasture or one hay field to basically where they're feeding. This one right here is a different hay field and also a 20-minute drive to feed, and it's $20, okay? But the thing about it is that structure that I just showed you with the barn alley feeder, it's $10 a bale, okay? So you're looking at a difference for feeding 30 bales, okay? In this case, you're looking at a difference of around $350, okay? That's, to me, that's a significant savings, all right? So then looking at other feeding sites, I got these 3 red ones right here that are right along the road, okay? Well, what these are is basically existing barns, okay? And it turns out that they fed 89% of their round bales were fed at existing structures like these barns, okay? So instead of, in my opinion, instead of having this centralized storage structure that you're passing by these feeding sites, why don't we take advantage of some existing structures and put hay in those so that we don't have to make this travel distance, which costs us more money. And then here's another barn where basically this 5 roll bale feeder is. Well, we could put roll bales over in this area right in through here, and you've cut your distance down significantly, okay? And I brought this up one time to a producer. I'm like, you store the hay here, you feed it here, and you don't have to drive very far. Just put the hay in the barn. And he said, no, I don't want to do that. And I'm like, why? What do you mean, no, you don't want to do that? And he's like, I don't want to move my boat out of the barn. And I'm like, oh my gosh, okay. So the thing about it is, okay, again, shifting gears, there are components of beef cattle production, okay? You need to have a feeding area or feeding areas. You need to have housing or shelter for those animals. You need to have watering sites. You need to have storage for the commodities, for your equipment, for the boat. You know, you also have to have sanitation or be able to clean up in these manure areas or in these barns, which also leads into nutrient management. And you also need to have livestock handling facilities. And my point is rather than look at these as separate components, why don't we put these things together where basically we assimilate them in one structure, where basically the hay feeding area also has hay storage in it. This also has bedding storage in it as well. So you're combining these things with these old designs. These are like 1950s and 60s designs where basically, again, you have loose housing, you have your handling facility. Right here is basically, again, that is a self-feeder right there, okay? But you can also incorporate manure handling facilities, and you can incorporate a lane so that you can get the cattle out to facilitate rotational grazing, all right? It's just looking at things as a centralized hub. So I got these other 2 areas right here. There's a little red dot that's right there, okay? And then there's another one that's way over here. Both of these feeding sites are 30 minutes away, and it's very expensive to feed at these sites. And that might warrant basically looking at doing some sort of development at those potential areas. But the thing about it is the size of the dot is very small. So there is not much hay that is actually fed there. So maybe we don't need to do anything at all. But when you get over into this side of the farm right over here, where you have the woods, it's basically creating a geographic isolation where you can't get the animals over to the handling facility easier. Maybe there needs to be something over here that needs to be done. I don't know. It's just something to consider and basically put a pencil to, all right? So I want you to consider something that basically what I pointed out to you was a 5-fold difference at that one feeding site. When I look at the other feeding sites that they have, I can find a 10-fold difference, okay? And so let's just say that what that means is if it takes me, say, 5 minutes to feed, then basically it's taken someone 30 minutes to an hour, okay, on another farm, okay? And so with that 5-fold difference, what I found is other studies have shown also a 5-fold difference, but they've also found a 7-fold difference and a 13-fold difference and a 20-fold difference and a 40-fold difference. So at that 40-fold difference, if it's taken me 5 minutes to feed, it's taken someone else 2 hours, okay, or more, all right? And so what you're looking at is basically these wide differences are basically large improvements in labor efficiency that could be made, okay? And again, there was 13 different feeding sites on this farm, and 89% of them were occurred around existing barns or structures. So why not we're thinking about combining these things it would be a good idea. Okay, now we're shifting just a little bit. Okay, so I wanted to show just an example to make another point, all right? This is where the hoop barns are, okay? All right, where the hay is stored, and that's where you're starting off with green. And so basically, back in the day, when we controlled this, a producer or a worker would basically have to drive on a tractor and basically take these roll bales and basically drive across to basically go to this feeding site. When they get to this point right here where it changes into a red line, this is a 55-mile-an-hour highway, okay? But it's a low-grade highway. When you get to this intersection right here, you need to make a left-hand turn, and you're making it that left-hand turn in front of a blind turn, okay? And these people are running 55 miles an hour as well, and this is an upgraded highway with guardrails and such. And then you drive down this way, and then you get down to this intersection, and now you mean to make a left-hand turn, again, in front of another blind curve, okay? And then you drive down this gravel road, and you get all the way down here to the bottom where this red circle is, okay? And so I want to make a point about this, okay? And the point is that's 1.69 miles one way. And of that, 0.72 miles of it was on a 55 mile an hour highway. When I looked at this driving time and this driving that was occurring, one of the things that I figured out is your driving time is about a mile an hour on average. It might seem like you're going 3 miles an hour, but when you count stopping and starting to spear that roll bale and to open a couple of gates, it turns out to be about a mile an hour. So this is a significant amount of time to do this. And also you have to open up 2 gates to feed in this area. All right. And so now I want to make another point about that same area. I showed you this image earlier where they're feeding basically out on this open exposed concrete, where basically that roll bale is sitting at about 6 inches of slop. And where this roll bale is sitting, there's basically about a 2% slope going uphill towards the barn roof. The barn roof is guttered. Okay. So there's that. And so this is looking at an aerial photograph of that same area. So when I have a roll bale right here, let's say it's a 5x5 roll bale. Well, that's about 25 square feet of surface area that's going to get rained on. And then I got this upper watershed area, which is whatever, 15 feet by 5 feet, which is also going to contribute because the water is going to move this way and drain towards that bale. Okay. So you're looking at around 100 square feet of water that's going to be impacting the nutrient content and value of that roll bale. Conversely, you can see where there was a ring feeder that was set up right here. So a roll bale right there, again, is another 25 square foot, but I got this open lot area, and I also have this roof area. Okay, so now you're looking at around 200 square feet of runoff and drainage that's going to impact that roll bale. Okay, so let's go back to this site. This bottom down here was the confluence of 3 different creeks. Okay, this area right here is a 155 acre watershed that drains to that feeding point, okay? And it's not 200 square feet. It's 6,751,800 square feet of water is draining to that area. You also have a 150-foot drop in elevation from this point right here to this point right here, or a 150-foot drop in elevation point from this point right here to that point right there. So basically, that's where they were feeding. Now, the thing is the reason why this was occurring, okay, was basically outlined in this. So they would start off with the animals in this red field. And when these animals were in the red field, their water was basically located right here, okay? And so after they grazed this field, what they would do is they would open up the gate to this field and let them have this white pasture. Well, there is no water in the white pasture, okay? So they would basically have to walk back to this water source that's back over here by the handling facility. And then at a certain point, after they grazed this down a little bit, they would open up the blue field, and they would let them have the access to the blue field, which is where this hay would be stored, and also has access to the creek, okay? So my point is this, the reason why they were doing this was basically water availability, okay? And it's not to pick on them, it's just to show them what was going on, okay? Because the point I want to make is of these 13 different feeding sites that are on this farm that are currently being used, I basically had to develop water at half of these sites, at least 7 out of 13, because water and feed basically go hand in hand. As soon as an animal eats, it wants to get a drink. So having a developed water source also goes hand in hand with developing these feeding sites. As far as where these feeding sites are located, that's basically these blue animals right here. And these are all located for the most part on a soil hydrologic group of a C, okay? I would prefer to be on a B soil, which is a really well-drained soil, but the only Bs I have is basically down in the bottom. It's well-drained soils because it's alluvial soils, but it's also susceptible to flooding, and it's nowhere near, I mean, I'm not going to have a feeding site for the whole farm down there. I have all these other ones. So this is the best I could do as far as a C group. And that's mostly because of the clay content that's in these soils, but also because there's a frag pan about 18 inches down below the soil surface. So it just basically has a hard time of draining this water. And so the point is you want to be on these summit positions, and you want to be in well-drained soils and away from water, not down here where 6.7 million gallons are draining to, okay? So the thing is, all this, okay, is basically simplification, all right? And simplification is the systematic development and use of an easier, quicker, and more economical way to do a job, all right? Labor saving is mainly a matter of simplifying and, if possible, eliminating the transportation of materials. It's also eliminating stopping the tractor to open a gate, drive through, get back and stop it again to close the gate, okay? And then figure out where to put the hay. We'll sell feeders and these permanent systems. You don't have to think about where to put the hay. So there's no gates to open on the systems that we developed. You're doing basically feeding without getting off the pavement. So there's really no need, if you were buying equipment now, there's no need for a four-wheel drive or a front wheel assist because you're operating off of gravel or pavement, okay? There's no need to go in the field because the rutting, basically the rutting of the tractor tires, especially when you overload it with a roll bale on the front and back, creates, extreme compressive pressures on the soil, and it's going to rut it up, quite a bit. And if you go in there often, you're doing more damage than what the cattle are doing. And then also the basic thing of simplification is you're reducing travel distance, okay? All of the practices basically I've shown you are basically labor saving designs, okay? They're engineered facilities, okay? What engineered facilities or labor savings designs do is they allow you to increase your profit by being able to manage more animals in a given amount of time. They're not going to increase your profit straight out because these practices cost money. It's a simple substitution of labor for capital, okay? But if you have the opportunity to expand, this is how you make more profits because you can manage more animals in less time. They eliminate drudgery. They create what we call continuous production because you're not feeding a roll bale every other day or whatever. These animals have access to 30 bales at a time, okay? So you get automatic operation without supervision. They create simplicity. Again, you're not opening the gates and driving distances. And in some cases, it's very slightly, you get better animal performance and quality because again, you're linking up the feeding system with a good water system. And you're also incorporating heavy traffic pads and whatnot. So you're not creating mud. Maybe you're providing ventilation, so on and so forth, or easier ways to clean the pad. And then but these practices are not, going to drastically lower production cost per animal because again, these practices cost money. And the other point that I want to make is maps are awesome. Okay. It provides me and you with the opportunity to see your farm in a different perspective. Okay. And they also demonstrate patterns and connections and relationships. But maps can also do other things. They can provide you with solutions. Okay. They can maybe provide you with a better life. Maybe they can make you happier because everything is easier once you figure things out. They can create projects for you to do, but they're worthwhile projects because now you understand where those changes need to take place because you've utilized these maps. So the whole point of this presentation was not necessarily to talk about, structures for winter feeding and everything, but basically to give you a different perspective so that maybe the next time you see your farm, you're going to see it with a different set of eyes. So that's pretty much all I have.
Thank you very much, Steve. So that was, I think, about 2.5 hours worth of material in an hour. So you slowed down considerably tonight. You almost got to Kevin Laurent speed, but not quite. So appreciate you slowing down for everybody tonight.
No problem.
All right. Do appreciate it. And we already have a question. If anybody else has a question, please type them into your chats if you would. The question we have, Demetria asks, how many years does it take to pay for the new hoop barn structure if saving $300 a year?
Well, the barn alley feeder was around 350 savings for 30 bales. So I could pay for that in 10 years, but you also, and that's just by the labor savings of that, but by storing hay inside, basically, I believe Ray Smith and Jimmy Henning did some studies that basically showed that the storage structure could pay for itself in 4 to 7 years. So when you combine the hay savings of storing inside versus the self-feeding, those are basically additive. What that ends up contributing, I haven't done the calculations on that.
Okay, I had a bit of a question. I really thought that was pretty cool. The one in the barn that has the sliding
Right.
feeding gates that go back. Do you have any issues? Does that thing sometimes get wedged or anything, or does that sliding component work good enough that it goes back pretty good?
It goes back pretty good. I've tried it out. We're not going to start feeding or actually trying out that particular structure probably until January, but I tested it and made sure the tracks are operating well. And so basically it's operating off of trolleys. And so basically it's got some spin to it and some give. So it shouldn't be too much of a problem.
Okay. The other thing I had was about that same one. As you get some wastage and everything, does that become any kind of an issue? Do you have to get well, I guess you haven't tested it yet, so we don't.
Well, okay, so it's a good point that you brought that up. And so really what it really boils down to is you need, in order to do these structures and for them to operate effectively, you need good quality hay. If you got some stuff in there that's got some trash in it that they're not going to eat, what that could do is end up balling up down on the bottom and causing some impedance of how well that thing moves. But again, this particular structure that we're utilizing, that barn alley feeder, is next to the Bar Optima hayfield. And the Bar Optima, I don't call it cotton candy, but I mean, they love that stuff. And so that's what's in that barn. And so we shouldn't have any problem with them cleaning it all up. Last year, we did some testing on the other large feeder that's got the hoop barn on it. And to me, it was almost comical. I mean, I got some pictures of the waste that they created, and it was negligible. And a lot of that is, again, it's the design of the feed barrier. Because what we've done on our feed barrier is basically put about a 22-inch barrier between where the cattle stick their head through and what leans up against or what rests up against the hay bale. So they have to stick their head through the gate in the feed barrier in order to eat. And by doing that, you typically get less wastage because they don't take their head out, especially when there's competition for, spacing. So that's one of the other things that we've also discovered.
Good deal. I had somebody send in a private question. Can you use the tires for outdoor holding / working pen areas with dense grade on top? And they followed up with, my thought is when scraping, cleaning, you would only get the dense grade.
Well, I mean, if you have the dense grade that's either level or below the tire rim or, that tire barrier, you're not going to take out any rock at all. Yes, I've actually installed several of these applications outside. I just did it in the last month with the good weather, and I'm going to evaluate those over the winter time as well. One of the optimum areas, I think, one of the optimum outside areas for putting in these tire cylinders is to actually put them on a slope, because what you've done is you've reduced the run of that slope to basically the 40 inches that you have inside that tire. So you're not going to get significant gully erosion occurring down a driveway or whatever, because you're only going a 40-inch length. Or does that make sense?
Yeah. No, I thought that was pretty. I hate to blow you up a little bit. I thought that was pretty ingenious too. That was pretty cool stuff.
Thanks. And I mean, they'd be great for access going into a pond, as far as a ramp going into a pond. Again, that rock's just not going to move. Right. But and for instance, when I'm traveling down I-75, your tires are basically operating, or in these two ruts that's been created by the deformation of the vehicle traffic going down the highway. But that's not what you should get with these tire cylinders, because basically the edge of those tires is basically controlling that lateral load. So, and again, for $1 a piece, but they're kind of heavy, and it's kind of like, and when you take the sidewalls out, they get kind of flimsy. So it's kind of like moving a dead body. So
I wouldn't know about that. All right, Steve. We have someone has asked, and Katie, you might have to pop on and answer this one. Where on Facebook can I find this recorded? Now, we do, I don't know if we have it on Facebook. Katie, you can chime in and say we will send out YouTube links. And I know everybody out there is saying, well, what about the last couple? Because I'm behind the times. But I hope to get those out to you guys very quickly. But we try and put all these up at least on YouTube. And Katie, can you let them know about Facebook?
Yep. So you're going to go to the KY Beef IRM is the name of our Facebook page. And this video will be out there. It's out there live right now. And then you'll be able to access it later as well. And then our previous videos are all out there as well as on the UK Animal and Food Sciences YouTube page. So I'll put all that in the chat. So that way you don't have to memorize what I just said. So I'll put that in the chat in just a second.
Good deal. That's what I thought, Katie, but I just wanted you to tell them. All right. So Steve had the question, where are the tire cylinders purchased from?
I found there might be two, but I've only been dealing with one. It's basically Porter Tire that's in Carter County. So that's on the eastern end of the state. And so we've made some runs down there to get these cylinders. And also we've also gone down there, see, when was that? Yesterday. And went and picked up some 8-foot tires that we're going to make into tire waters. So that's kind of my getting place for tires. There might be a place in Shelby County that might do the same thing. There's also, if you're in Western Kentucky, there's probably a place out of Nashville that you could get these things out of as well. Yeah,
I wonder if there, I was just trying to think of how would you even start into that? Where did you kind of find out about your place to start with? I mean, is that a Google search or?
Well, there's the Division of Waste Management, which is a state division, has a tire amnesty, a recycled tire program. So basically I reached out to them to see if there were some tire recyclers that I could reach out to and find this product. All right, here's a kicker for you. All right, are you ready? So this concept of taking these tread cylinders and putting rock in them is actually patented. I kid you not. It is called mechanical concrete, okay? For what that's worth. But anyway, yeah, so I reached out to the Division of Waste Management, found them, started making some phone calls. There's another guy around Shelby County that uses these tires for to make blasting mats, because they're basically indestructible. But and you see some of these mats as well where they'll do a weave, in some operations where they'll use them around handling facilities or something like that. But again, it's just one of those things of taking someone else's trash and using it to benefit on a farming operation and also save some cash as well.
So Kevin's asking, do you have to cut the sidewall out yourself?
No, the company, these recyclers, basically the process is they get these tires, they're paid to take them, to my knowledge. And then what they do is they take the sidewalls out, and they normally sell the sidewalls to, say, dairy producers or whatnot that want to use them to hold down the plastic on silage bags, which you've seen, and they interlock them sometimes. The tread cylinder, normally what that would happen is they would basically run that through a chipper grinder and then pull out the belts, the steel belts that are in there, and that goes into another tote. And then basically they make any form of anything from crumb rubber to shredded rubber for applications on whatever, playgrounds, pavement situations, asphalt, whatever. So basically I just reached out to them and said, I want the cylinder. I don't want the sidewalls. I want the cylinder.
Brian said there's also a place in Nelson County that has them.
No kidding. Okay. And these are not regular car tires. These are semi tires.
And Carol Hinton saying that they have some folks that build some of these products out of tires in their county as well.
Yeah.
So good deal. I tell you what, all these uses for tires, it's amazing. I just thought we drove on them, but it's amazing all the farm use that we have for them now. Mm-hmm. So it's a good deal. All right. While you guys are thinking of another question or two, let me draw your attention to the screen. The next of our Reaching Out While Locked In webinar series is going to be structures and working facilities. We're hitting the month of November hard with the ag engineering types. And so we have Dr. Morgan Hayes and Dr. Josh Jackson that are going to be your presenters. And that's 2 weeks from today. If you're needing the CAPE educational credit for tonight's session, that code should be Beef Build. And that would go in the part where the presenter's signature normally goes. Talk with your county agent. They're the ones that have to qualify these sessions as CAPE acceptable for the educational qualification. So check with your county agent about the forms, but that is the code if you need to use that. I want to bring your attention to one other thing. Uh-oh, that's not what I meant to do. There we go. Dr. Limcooler and Anderson and myself teach the beef cattle sciences class, and our students do county presentations at local extension offices, but due to our situation this year, most of those programs are going to be on Zoom. We have at least one Zoom session next week on Monday, Tuesday, and Thursday night. If anyone is interested in coming and listening to the students, they give a very basic beef production kind of a talk. 4 students give the presentation at each of these. One speaks on nutrition, one on reproduction, one on health, and one on genetics. So they last about an hour. If you're interested, I'm going to send out some information about it. So check your email where you normally get these invitations from me. And if you're interested, I'm not going to send those invitations out to everybody. If you're interested in participating one or more of those nights, just let me know which night you're interested in, and I will send you the invitation for those, and you can come help support these students. They do a good job with it, and I think you'll learn something as well. So if you're interested, let me know, but I'll send information out tomorrow regarding that. Someone says, will the certificate be emailed? No, we don't handle that. That's what I say. You have to talk to your county agent. They should have the forms that are necessary, because I think they have to sign it as well. So check with them as well. Brian also put the place in Bardstown, the address for that. If anybody's interested and you're close to the Nelson County, he put the address in the chat session for that as well. Steve, any last remaining thoughts, or any of the rest of the specialists? Anybody have anything? Not seeing any other questions, at least at this time.
No, I'm good.
But thought it was an excellent job, and we appreciate it, Dr. Higgins. And if we have nothing else, I'm going to close it for tonight. I want to remind everybody, please stay safe, stay healthy, and hopefully we'll see you in a couple of weeks, and hopefully see a few of you maybe even next week for the student presentation. So take care, and we'll see you guys soon. Good night.